Swayam Prabha. Digital India. Educated India.
Hello everyone. So, today we will continue with the understanding that we are creating on Euler angles and ODFs, and this is lecture number 16, and we are doing module 4 on texture representation. So, today what we will do is that we will try to represent the crystal orientations in terms of the Euler space, in terms of the Euler angles phi 1, phi 2, and that is basically what we are trying to do, that we are trying to trace back the Miller indices in the Euler space. So, we are basically trying to construct the Euler space. So, this lecture is basically related to the construction of the Euler space utilizing Euler angles phi 1, phi 2. So, let me first draw the Euler space, right. So, as in the other slides, I am trying to draw the Euler space, and this is the Euler space, right. So, this is 0 degree for the phi 1 section up to 90 degrees, and we will do this construction for the cubic crystal, and therefore, we will always have phi 1, phi 2, which is starting at 0 and ending at 90 degrees, right. So, this is the phi 2 section. So, any orientation that is 1 0 0 0 1 0 or and 0 0 1, this is used to represent the crystal coordinate system, right. And in order to represent texture, we try to make the important sample reference system, which in most of the cases we are using RD, TD and ND, because most of us are familiar with rolling, and we try to coincide the important sample reference directions, that is RD, TD and ND, with parallel to the important specimen reference direction, which is basically the 1 0 0 x axis, right. So, you see that in order to construct the Euler space in terms of the crystal orientation HKL UVW, what we need to do is we need a sample reference system like we draw here, and the crystal reference system as we have drawn here. So, let us say phi 1, phi 2, here we are keeping it for writing this in form of a table, right, and here we will keep HKL UVW, right. So, we will try to write the HKL UVW corresponding to as much as possible phi 1, phi 2. So, let us take the first condition. The first condition is the condition where phi 1 is 0, phi is 0 and phi 2 is 0, and the condition of this will be such that RD is parallel to 1 0 0, ND is parallel to 0 0 1 and TD is parallel to 0 1 0. So, the HKL UVW for this first condition, which is basically the starting condition itself without any rotation, is 0 0 1 as HKL and 1 0 0 as the UVW, that is the rolling plane and the rolling direction, right. So, now let us write this position in terms of Miller indices in the Euler space. So, this position is basically 0 0 1 1 0 0, right. So, you see that when we are finding out the texture components, and we gave example of cube component, rotated cube component and Gauss component in the earlier lectures, and we are rotating phi 1, phi 2, that is we are rotating the sample coordinate system N d, that is phi 1 rotation, right, by the right hand thumb rule, then R d, that is the phi rotation by right hand thumb rule, and again phi 2 rotation which is along N d using the right hand thumb rule. But when we are tracing back the crystal orientation while we rotate the sample coordinate system, we should remember that we have to exact rotate in the reverse sequence, right. So, we need to rotate first by phi 2 and then by phi and then by phi 1, and this time we have to use the inverse of the right hand thumb rule, that is we have to use the left hand thumb rule, because we have to rotate opposite, we are tracing the crystal orientation in terms of the Euler angles. So, instead of the right hand thumb rule we have to just do it opposite. So, let us see how it is done. So, let us say that the first condition that we showed is the 0 0 0 1 condition, which is this one, right. I will not write it here. So, this was the first condition, right, this one, right. The second condition, let us say the second condition, this is the first condition, this is the second condition, is phi 1 0, phi 0 and phi 2 90 degree. So, the 90 degree rotation is not by the right hand thumb rule, but just opposite to it, that is the left hand rule, right, or the opposite of the right hand thumb rule, like this, right. So, let us use the green color to show how this rotation is done, right. So, the rotation is basically now like this, right, instead of this. So, if we rotate N d by this, then what will happen? The T d will come here and R d will go there, right. So, let us draw how it will look like, how the specimen axis will look like. So, R d will be, now the T d is here and the R d is here. So, for the 0 degree, 0 degree, 90 degree, the HKL planes for the N d remains the same, that is 0 0 1, and the R d becomes opposite to 0 1 0, that is 0 1 bar 0, right. So, let us show the position of the second position. Okay. So, here 0 0 0 is shown by here, this position in the Euler space, 0 0 90 degree, that is phi 1 0, phi 0 and phi 2 equal to 90 degree can be shown by this position, right, and this position is basically 0 0 1 0 1 bar 0, right. So, we have traced two Euler crystal orientation in the Euler space, right. Let us trace the third one, and what is the third one? Let us take 0 degree, 90 degree and 0 degree, right. So, if we do that, let us say this is the third one, and if we do that, we have to take this one and we have to rotate by 90 degrees along R d by the left hand rule. So, we have to rotate just opposite to that of the right hand. So, you see how the rotation will be. So, initially it is R d and then it is T d and then it is N d here, and we are rotating like this, like this. So, it is the using opposite of the right hand, and so this will become So, this will become R d will remain R d. Let me change the color for clarity. R d will remain R d because we are rotating along R d now, and the T d will go down and the ND will go here. So, for the third case, ND is becoming parallel to 0 1 0 and RD remains parallel to 1 0 0, right. So, I can show the position in Euler space, that is phi 1 0, phi 90 and phi 2 equal to 0. So, this position is basically 0 1 0 1 0 0, right. Now, let us check the fourth condition. The fourth condition, let us say it is 90 degree, 0 degree and 90 degree. So, the condition will be similar to the, you see, the second condition, right, where the ND is basically rotated so that it forms TD here and RD here. So, this is equal to the second condition, right. So, you see here the I have written it a little wrongly. So, I am tracing the 90 0 and 0 degree, right. So, it is the same rotation which we gave in the here, where we have rotated 0 0 and 90. Now, we are rotating 90 0 0 and therefore, the rotation along phi 1 at 90 degree is along ND, which is similar to the what we have done in the second one. So, the Miller indices will remain the same as in the second one. So, one can see repetition on the Miller indices even in this Euler space, which had been shortened from 0 to 360 degrees along phi 1 phi 2 to 0 to 90 degree because of the cubic symmetry, right. So, you see phi 1 equal to 90, phi equal to 0 and phi 2 equal to 0. So, the position is basically here, which is 0 0 1 0 1 bar 0, right. So, the fifth situation could be 0 degree, 90 degree and 90 degree. So, you see, as I have said that we have to trace the specimen sample axis to the crystal sample axis, and in this regard we are tracing the HK LVW in terms of phi 1 phi 2. So, thereby we are doing it in the opposite direction, right. So, in order to trace the fifth one, we have to do phi 2 section rotation first by the opposite of the right hand thumb rule and then phi section rotation by 90 degrees. So, the phi 2 section rotation is already given in the by 90 degrees already given in the second condition, which is this one, right. And then we take this and we add phi equal to 90 degree section, phi equal to 90 degree rotation, and then what will happen is that we are giving along RD opposite of the right hand rotation, which is basically this one, right. And then when we are plotting this, what we are observing that RD remains the same, right, RD will remain the same, and then you see ND will change and it will form here and TD will form here, right. So, RD remains the same. So, you see that in this case the ND becomes parallel to 1 0 0, whereas the RD basically becomes parallel to the opposite of 0 1 0, that is 0 1 bar 0, right. Now, let us put this in the Euler space. So, it is phi 1 equal to 0, phi equal to 90 and phi 2 equal to 90, right. So, the position of this is here and this is basically 1 0 0 0 1 bar 0, right. Now, the sixth position. The sixth position is, let us say that it is 90 degree, 0 degree and 90 degree. So, again for the sixth position, let us take the second one and give a rotation at phi 2 equal to 90 degrees, right. So, if we do such, then what will happen? We are rotating again by ND, right, and not like this. Basically, what we are doing is that we have to rotate it like this, right, opposite of the right hand thumb rule, and thereby what will happen, the T d will come here and the R d will go there, right. So, let us draw it. So, here is the N d and here is the R d and here is the T d, right. So, you see the N d remains 0 0 1 and the R d became 0 1 bar 0, right. So, let us write the sixth one, and which is 0 0 1 0 1 bar 0, and so you see phi 1 90, phi 0, phi 2 90 is this position, which is basically 0 0 1 0 1 bar 0, right. So, the seventh situation could be, you see, 90 degrees along phi 1, 90 degrees along phi and 0 degree along phi 2. So, you see the seventh situation could be taken as the situation that we have already done given, that is a rotation along phi in the third condition. And so, if we take this particular situation, that is the 3, and plus if we do a phi 1 equal to 90 degree along N d again. So, let us take this one. So, we will write N d and this is R d and this is T d, and so this is after the phi rotation along R d, and thereby if we give this rotation phi 1 rotation along N d, which is by the opposite of right hand thumb rule, then R d goes up and T d goes to R d. So, this looks like N d will be the same and R d above and T d here. So, you see the N d now becomes parallel to, so I am writing it directly here, parallel to the 0 1 0, right, and the R d is basically parallel to 0 0 1. So, let us write this position in the Euler space. So, you see phi 1 90 and phi 90 and phi 2 equal to 0. So, we have got this position, this is 0 1 0, right, 0 0 1. Now, we need to trace another position, which is basically the 8th position, and that is 90 90 and 90 degrees, right. So, in that case it is better to take this one, because we have already given phi 2 90 and phi 90. So, let us take the 8th position, sorry, eighth position. So, that is basically the rotation that we give in the fifth one, that is the rotation of phi 2 by 90 and then phi by 90 using opposite of right hand thumb rule, plus we have to give phi 1 equal to 90 along N d, right. That is an N d rotation using the opposite of the right hand thumb rule. So, which one is the fifth one? So, we will have to use this particular one, right. So, we have to use this and we have to rotate by 90 along N d using the opposite of right hand thumb rule, which is this, thereby bringing R d above and T d to R d. So, if we draw this here, then N d remains in the same direction, R d goes up and T d goes here. So, you see the N d basically of this position is 1 0 0, whereas the R d becomes equal to 0 0 1, right. So, if you see that this is a position where phi 1 is 90, phi is 90 and phi 2 is 90. So, thereby this position is 1 0 0 0 0 1. Now, that we have found out and calculated all the corners of the ODF, and of course, all the corners of the ODFs are related to the cube texture components, but you see that one can find out the other texture components also by giving simple additions. Now, you see just to tell you here, it is very important to know that when we are giving the rotation along this phi 1 angle, the rotation is basically along ND. So, the ND component will not change. The component that will change is the RD, and therefore, this kind of a fiber which goes from here, let me show by color, say from here to here is basically known as the ND fiber. And then you see if we try to find out the position which is at the center here, then you see that in this component will have an H scale which is 0 0 1, which is known because the ND is the same. So, the rolling plane is same, but if we see the rolling direction, at here it is 1 0 0 and here it became 0 1 bar 0. So, the rolling direction, if we add 1 0 0 and 0 1 bar 0, it becomes 1 1 bar 0, right. So, you see that we could trace the Euler angle for which the Miller indices is this one, and the Euler angle basically of this position is 45 0 and 0 degree, right, phi 1 phi 2. Now, if we trace the Euler angle 0, 45 and 0 degree, that is this position, then you see that at the rotation of phi is basically along RD. Therefore, the rotation axis is RD. So, phi represent the RD fiber, right. So, the RD will remain same. So, you see 1 0 0 and 1 0 0 for both these components remain the same, whereas the ND component, that a rolling plane, become 0 1 0 for this and 0 0 1 for this Euler angle, right. So, like that one can find out the components in between this, in this line which is parallel to phi 1, right. So, you see in here also it is the ND component, because the 1 0 0 which is the ND texture remains the same. So, 1 0 0 remains the same, whereas the rolling direction changes from 0 1 bar 0 to 0 0 1. So, this is 0 1 bar 1, right, addition of these two. Like that, various other texture components can be observed and can be depicted using this Euler space in terms of Miller indices. Say for example, the component which is at the center here is basically 0 1 0, right, 1 0 1, right. So, you see here also the rolling plane or the is constant. So, this is parallel to ND and the component which is along RD is 1 0 1, right. Like that, one can trace each and every component of the Euler space, that is each and every position of the Euler space which is in phi 1 phi 2 in terms of H scale, EVW, Miller indices by using a rotation which is basically opposite of the regular trend, that is the specimen axis is rotated by phi 1 phi 2, that is a rotation along ND, RD and ND to go to the crystal axis by the Euler criteria following Bunge's way of rotation. In order to trace back the H scale UVW plane, thereby we have to rotate the specimen axis by first phi 2 opposite to the right hand thumb rule, and then by phi, and then by phi 1 following the opposite rule, that now we have to rotate using the opposite of the right hand thumb rule, that is the left hand thumb rule basically. So, as to trace back the HKL UVW of the crystal. So, this is all today's for today's lecture. In this lecture, what we have found out is that we can trace back the HKL UVW in terms of the Euler space. So, the Euler space can be represented in terms of the HKL UVW, and one can trace enormously, and thereby one can find out the relationship between the Euler angles and the HKL UVW. I will request the participants to practice this geometrically, these geometrical rotations, so that one can understand how this Euler space has formed, and then one can even go and make orientation distribution functions from this Euler space in terms of phi 2 sections, right, at phi 2 equal to 0 degree, 5 degrees, 10 degrees, and we can make it up to 90 degrees, and see the positions of the HKL UVWs, various positions of HK UVW in it. So, we give a small example. I will give you a small example. Say for example, gauge texture, right, and we have seen the position of the gauge texture in this Euler space. Now, if we are adding 0 0 1 and 1 0 0 and 0 1 0 1 0 0, we can see that the 1 0 0 is common, and so we are adding basically 0 1 0 and 0 0 1, right. So, this position which is basically at 0, 45 and 0. So, this is a position 0, 45 and 0 represent the position of the gauge texture. In the similar way, if we are adding, you see this and this, where the RD 0 1 bar 0 is constant, and we are showing the texture which is basically the position 0 degree at phi 1 and 45 degree at phi and at 90 degrees to phi 2. So, if we are adding, then we are adding the rolling plane, that is 1 0 1, and then the rolling direction is 0 1 bar 0, and so we are seeing here this position. We can observe the the gauge texture. Again, we can add this position, and the position of the gauge texture basically here is phi 1 90, phi 90 and phi 2 45, that is this one, that is 90, 90 and 45. So, this position, and therefore, if we see that again the RD component is same 0 0 1, therefore, it is an RD fiber. Now, you can see that this texture, if you add the rolling plane direction, that is ND, it becomes 1 1 0 HKL and 0 0 1 UVW. So, you can see that by using, one can observe various kinds of texture, and in this case we have shown the example of the gauge texture component that can be observed from the trace of the HKL plane with respect to the Euler angles. So, from this lecture course, we these sessions on Euler space and Euler angles, we could find out that texture components can be represented in terms of Euler space and orientation distribution function, and then the crystal orientations, important orientations, that is HKL UVW, if it is in terms of rolling plane and rolling directions, can be related to these Euler angles phi 1 phi 2, and can be used to construct the Euler space and thereby the orientation distribution functions. But we should remember that the construction of the Euler space using this HKL and UVW, the specimen axis has to be rotated by phi 2 phi 1 opposite to the right hand thumb rule. Thank you very much.